Hi everyone, my name is Sanjay Vyas. Thank you for coming down here today. Um, Today we are going to talk about a very interesting topic in telecom industry, which is detecting fraud, analyzing fraud at big data scale. So before I do that, just a brief introduction about myself. So I have around 17 plus years in telecom, in overall information management experience, working at various Fortune 500 customers like Bank of America, Hewlett Packard, and so forth. So I co-founded Deota, which is a big data software company in 2011, and had been fortunate enough to be part of the initial architecture and the technology which went into building the product. So before we get into the real subject here, I wanted to go through some of the business glossary items which we'll be using, which I'm pretty sure if you have come to this session, you would be having knowledge about the telecom fraud and the telecom data in general. So CDR, which is called data records, they are generated by any call we make as subscribers, whether through our mobile phones. Those are that generate an activity which is basically captured as a call data record. And of course, with the advent of mobile technologies and smartphone, we also have IPDR, which is IP detail record, which has surpassed the volume in terms of call data records by gargantuan proportions. So that's generated by any browsing activity, like whether it is you're going through to a website on your mobile phone or social media. Any sort of browsing activity generates an IPDR. And IVR, of course, it's an interactive voice response system, which is typically used in majority of the telecom systems for typical queries. So, so let me just ask one question from all of you. While you are at Hadoop Summit and looking at a lot of big data use cases, how many of you are from the telecom background or have some experience, or are working in that industry to solve some of the big data use cases there? Just getting an idea here. Just raise your hands if you're in telecom background. So, so not many. So, well, so how many of you are implementing big data in general? Forget about telecom, just in general. So that's great. So basically, the applied aspect of the big data in general, right? So the high volume data ingestion or high frequency data ingestion into an enterprise data lake is basically the use case here if you really look at it, which we're going to go in the details. So let's go over to the next slide here. So why it matters for telecom industries to analyze fraud? So globally, telecom is approximately $2.2 trillion industry. And out of which, if you really see there's a major portion of those lost in revenue, 46 billion to the order of $46 billion annually are lost in fraud. And what type of fraud you see? Generally, you would see people using somebody else's account, which is called a subscription fraud. You will see roaming fraud, international revenue share fraud. So there are so many different holes in the telecom, the usage aspects of it that they have to detect. In many cases, they have to detect the fraud within a very short amount of window. So as you can see, it really matters to all these different telecom companies to analyze and detect the fraud as soon as possible so that they can do a stopgap measures and apply the preventive techniques to prevent the loss of revenue. So, so as I was talking about the various data, like different data source systems within the telecom industry, which pretty much, if you look at it, these are the records generated at a very high speed and generate a lot of volume. So just to provide some sense of it, I have also just a little bit of animation here. So if you really see, like, what's happening is the subscribers who are like people like us making these calls and browsing, like browsing on our phones, that and plus any IVR calls, that generates those high volume real-time data, which is going over to the analysis side, where typically in the traditional world, what was happening is that you had monolithic applications which will collect that data to some extent, like but with the advent of big data and the smartphones and the mobile technology, what has happened is the volume has grown enormously. I mean, previously where these applications, fraud analytics applications, were built upon like a two-tier architecture with Oracle database and regular RDBMS and web application on the top. They would analyze that small amount of volume, but with the mobile technology, the data has grown tremendously. So in our use case, with which we have implemented best practices along with like Hortonworks, we are generating in a day around 9 terabytes of data, so which is pretty high in terms of the data being generated, which needs to be analyzed. So now if you look at it, you have a large heap of data, and within that large heap, you have to detect the fraud records, which are like very tiny bit. I mean, you have a small amount of data which could be suspicious. So the overall use case in this particular scenario is like you have a real-time streaming data as well as the file-based data coming into the infrastructure, which needs to be harnessed and analyzed for the detection of those suspicious records. At the same time, what really matters from business perspective is that not only they want to do the prepackaged, like predefined apply fraud rules, but they also want to do real-time analysis, which makes a lot of sense in terms of doing some kind of predictive analytics and those kind of things. So that being the business use case, as I was telling you, the legacy state for fraud analytics was very much limited to capacity processing, as well as cannot do on-demand real-time analytics. So there was no provision to do real-time analytics at all. So this customer who we started working with, they had these challenges where they could not even analyze the IPDR data, which I was explaining before, because of the sheer volume. They could not ingest the real-time data because that particular system, legacy system, was not enabled to do that. And of course, there was no capability to do on-demand real-time analytics. So of course, there was Hadoop being taken into account in terms of having a solution which could perform data processing, data storage, data archival. But again, when you look at adopting Hadoop, the challenges which the IT team was facing in order to adopt Hadoop was from a skill gap perspective, the skill gap perspective, as well as the cost perspective. So the skill gap perspective, as I was telling you, the legacy state for fraud analytics was very high. I mean, you have a small amount of data which the IT managers who were tasked with delivering that project, ingesting the real-time data into their data lake, they had skill gap. They had a team who came from the regular information management background, and they didn't have in-house expertise to keep the pace with the evolving technologies like within the Hadoop ecosystem, which we are all very much aware of, whether it is Spark or streaming, Storm, all different stack in the Hadoop ecosystem. And of course, at the same time, they wanted to build something which is sustaining, even like if they build some an application which has to be a manual coded application was not an answer to the sustainable application which they were looking for, just because it introduces so many data quality as well as the maintenance issues, and plus leave aside the inconsistent approach for development of those applications. The other challenge was very interesting in terms of scalability. So when you are developing Hadoop data lake within your enterprise, you have to, within our last 3 years itself, we have seen the evolution, how things have changed, like how we were initially so much doing everything with MapReduce, but as we started looking at other processing engines like Test came in, Spark came in for in-memory processing, and then even now we see like a lot of other evolution within the processing paradigm. So that scalability was a big challenge for them. They didn't want to build something and then again rebuild it after some few months or year. So they had that, and of course the metadata capabilities of the platform, in sense like you have you're developing a lot of code, you're building like so many different data ingestion processing pipelines, but how do you make sure that all of that data is governed and you have the lineage to prove to the compliance and regulatory authorities. So what were the solution components? So we, of course, within their Hadoop ecosystem, they chose the Hortonworks data platform. For data integration, Diota, which is our company, was chosen as the enterprise data integration platform. And of course, for analytics purposes, they chose Teradata. So let's look that in a little bit of detail, what we're talking about here. So as you see, in a typical enterprise data lake implementation, you have different types of feeds, different type of data, which is being sourced, and then lands in your data lake. And then on top of that, you have to really, like, you have a window of 5 minutes, like in this case, to apply the rules and pick up the suspicious records and send it over to your traditional fraud analytic application. So what we did was we had, Diota provides an agent-based architecture which allows for distributed processing and the workload management. So no matter how many feeds you have, no matter what volume you are ingesting or the frequency at which you are ingesting, you are able to scale that with the agents. And you can ingest any amount, any type, any volume of data into your data lake. So within Hadoop ecosystem, we also were using Hive and HBase for processing and transformation. And then the plan was to scale that to Spark so that you can leverage this streaming capabilities of Spark. There were provisioning requirements as well. So all data which is going into Hadoop has to be provisioned out to the analytical application, whether it is Teradata or the traditional fraud analytics application. So that again was driven through the agent-based Diota provisioning. So let's look and let's take a deeper look at the technology which we have built with Diota. So what we have is a very open, loosely coupled technology stack, which allows you to scale in terms of sourcing, which is on the left side, you have to source batch type data sources or traditional sources like RDBMS and files. But at the same time, you also have to source the modern type data sources like XML, JSON. IoT is all about getting the JSON data from collectors. At the same time, streaming sources like JMS, Kafka, and cloud-based source systems. So Diota provides that through the data ingestion capabilities. And from the processing perspective, we have kept it open architecture in terms of using any type of processing paradigm. So you could be using Hive. You could be using Hive again with different flavors, and then Spark as a native processing engine. Then within streaming side, you would be going with Spark Streaming, Storm, Flink, those type of processing. So again, we have kept it open in the sense what we do is we build those components so that you can execute the processing code on those particular engines. And the ease of use, we have our foundational principle is that to make sure that the developer studio, whether it is building the ingestion pipelines or creating the processing paradigms, like building the processing transformation rules within your data lake or provisioning that data out to any system, we just kept it very user-friendly. So even a data science community, like we have Sprint as a customer where data science community is using Diota to do on-demand data analytics. So that's from our data integration platform architecture. So let me tell you how the overall how it works in action. So as I was telling you about agents, so think of it as let's say you're working in a multi-country type deployment where you have data lake in the cloud, and you have data coming from different countries. Like in one of the use cases we're working with right now, they have data which is sitting in South American countries, Mexico, Chile, and so forth. So they want to encrypt the data at source before it actually leaves that country because of the global compliance rules. So that again is manifested through the agent. So we have lightweight agents. These are like Java or Windows-based agents which sit on your source side, near source side, where they can do encryption, compression, and then on the target, you would again have, so there's an agent-to-agent communication. So Diota as a controller manages all the orchestration and processing algorithms while you build those through UI. So you have Studio, which is again very user-friendly, and then at the runtime, those instructions are being sent over to these agents, which can then communicate, ingest, extract, process the data within your data lake. So another interesting point about this technology is that it doesn't limit you into just one particular, say, big data platform, because in many of your applied use cases, you would see it's not just about Hadoop. It's also about the other analytical systems which are next to Hadoop, like could be a data warehouse or could be an operational system, could be cloud, could be Cassandra, NoSQL. So all those different processing engines or the archival storage systems have to talk to each other. So that's what Diota provides you, a unified way to approach all these different systems, and then finally, provision that data out. So I want to play a video which is basically the same challenges which our customers have faced, and I want to play that for you to hear it from them, and then we will open it for questions and answers.
Sprint bought an enterprise license for Diota, So the problem was our Sprint fraud team only had the ability to analyze voice usage and not data usage because of the volume and velocity of the data. We didn't have a location where we could store that magnitude of data. So we decided that we were going to leverage our newer Hadoop platform as that target location. The challenge was we didn't have any resources in-house who could move data into and out of Hadoop. So we needed a solution that we could deploy quickly using our existing resources. So the primary criteria we looked at when we were evaluating data integration tools on Hadoop was finding a tool that our business users and our existing IT resources would be able to leverage without having to have an underlying understanding of Hadoop. And just as important, we needed a tool that would seamlessly integrate as newer open source technologies came to be that we could leverage and not have to rewrite anything on our existing platform. And then finally, we wanted to also make sure that we could use Diota in the traditional ETL sense, so we can start looking at sunsetting more expensive legacy ETL tools. The project we deployed with Diota took about 4 months, and we had over 100 feeds that we broke up into 5 iterations. The timeline that we deployed this was about a third of what it would have been, and about a quarter of the cost that it would have been had we brought in a vendor to custom code this for us. We're loading over 12 billion records a day, so very high volume and velocity. So the project was considered a complete success. It was delivered on time, on budget, and with quality. The tool met and exceeded all our expectations. And in addition, Diota as a company has been a pleasure to work with. They've been a great partner from a professional services standpoint. They're very responsive to any questions, concerns, or issues that we have. So we're planning to continue to use that as our data integration tool of choice on all Hadoop projects going forward.
So that was our customer testimonial video. And so again, my name is Sanjay Vyas. I'm a founding member of the company as well as Chief Operating Officer.
How the fuck you doing, Austin, Texas?
Sorry about that. Well, we always need some fun after the presentation there. So, all right. So I'll just open it for questions, Q&A. Yeah, please. Yeah. Yeah, so the fraud detection rule-based engine is actually Minotaur, which is a proprietary tool built by that company. So they are basically architected for managing a small volume of fraud and suspicious records based on certain rules which are applied beforehand. So that's where you are applying that in the Hadoop data lake, and to extract those suspicious records and send it to that rules engine. So, yeah. Yes, so it's all getting into Hadoop and then getting stored in Hadoop, and the life cycle of that data is really short because it's such high volume. They don't want to like store more than 24 hours of data, but it's like almost 8 to 10 terabytes a day. So. It's actually more of Hive tables because of the reason that they are doing this this analytics piece here. So what they want to do is they want to store the data in a user-friendly format, so the power users can use on-demand analytics rules and then generate their own extracts, which can be analyzed through their data science team. HBase is also utilized for control and auditing purposes. So they have around 100 plus feeds. So all those 100 feeds have to be audited, like which file came in, how many records came in, whether it was loaded successfully or not, and those kind of things. So that's what they do in HBase because it's more transactional friendly database.
These feeds are not data like a network feed?
Yes, exactly. So. So these are all network feeds coming from directly from the network, and it's like a non-stop 24/7, 365 because subscribers are always making calls, right? So they have prepaid, postpaid, all types of data. So billing, so all that comes from the network, I mean, it lands in like real-time data is actually ingested through messaging, and then the regular data is coming through the fixed width file. Yes, please.
Is there any machine learning in
Yes. So in Diota, yes.
or to say that there's been an anomaly or say that there's been a suspicious activity going on?
So that's, pardon?
That's in-house, you're using their.
Exactly. So yeah, so her question is about machine learning within Diota itself. So we provide generic capabilities in sense like you can apply those algorithms and UDFs within Diota. And we have prepackaged ingestion routines to get data from like CDR, IPDR type records, because these are standard formats. However, for applying the machine learning, you can apply that, but we don't have like a prepackaged type solution within Diota.
So basically, Sprint already had the
How-
ML algorithm and whatever to do it, right? So your value add is basically on big data filtering or.
So our value add, yeah. So the question is about the Sprint already had the mlib and processing algorithms. So what's Diota's value add? So our value add is to enable them with the data ingestion, processing, and provisioning pipelines. So it's basically the whole 9 yards about moving the data into your data lake, processing that data in a near real time, and then provisioning that data again to their rules engine, like the engine which is actually analyzing the fraud data. Filter it out actually from the whole, like say 12 terabytes of data, they're probably passing maybe a few GBs out to the fraud analytics team. So those rules are being applied through Diota. So the ingestion, which is again, the high-speed ingestion, it's not like scooping the data. It's actually fast with our connectors and parallel optimized ingestion parameters. So all that data gets into the data lake, like it's running every within a minute. You're like loading gigabytes of data within the data lake.
Your connector works with any source?
Yeah. So our connectors, like we have several. You can have any type of source systems, whether it is streaming as well as the batch type or the modern as well as cloud APIs. So we work with all the connectors.
So from 12 terabyte to 2 GB, what is the logic used to filter and how?
So in terms of applying the logic, that's all business driven, right? So they apply the logic based on, let's say if you are making a couple of, like if a call, when every phone has a unique identifier. So one logic I'll tell you, like IMEI number is the unique identifier. So any call record has the IMEI number. So if they get a call like from the same IMEI number, but the location is different, so one is from New York and the other is from Miami, you know that there's something wrong there. Within 5 minutes, you can't be at that separate location. So from the client, yes. Yeah. Yes, please.
You talked a little bit about where your agents are running, how the data is flowing, how the customer looks back at it.
Oh yeah, sure. So again, I would like to give you an example again. Like say, you have data lake sitting in the cloud, say in Amazon, and you have.
Per customer, per client, or you would run a shared?
No, yeah, it's a per customer, So say customer has the data lake in the cloud or on-prem, doesn't matter. But let's say their data is sitting somewhere in diverse location in data centers which are probably outside of that data lake location. So in agent, what they do is they allow you to go all the way to the source. So you can you can install an agent within like near data center A. And if you have encryption requirements, you can do that encryption. So that's like a push configuration from the source side. However, if you don't need that push configuration, you can always use the edge node agent, which is the only component which we install within Diota, for data like for pulling the data. So that's the pull configuration. By default, you have pull configuration. So in order to like enable the push from the source side, you can use that. Other than that, like say we're talking about high frequency ingestion, right? So if you want to do workload management, so we know that the browsing records are way coming faster than the call records. So we have dedicated set of agents which are just managing that particular data ingestion pipeline. So
you are responsible for ingestion from their edge to the cloud?
yes. Yes, so we are responsible. So you would have like an agent capacity matrix where you will put the requirements in, and we will define like, do you need a source agent or do you need only the default set of configuration which will allow you to do that type of pipeline. So
You get a complete CDR record or you get the call legs?
no, you get the complete CDR. I mean, again, it's configurable. In this particular use case, client decided to get the whole call data record, which comes from the network. So it's all fixed width record, which maybe you're aware of as well. So those fixed width files would come and land from the network, and then you have to ingest them as they come. So we are working towards building the architecture in such a way that it evolves by itself, and it doesn't become a bottleneck like how we have seen ourselves. Like I come from like information management architecture experience as well, and I have seen how tools have become bottleneck. The integration tools have become the bottleneck while you start experiencing the new requirements or the architectures. So we have our vision to not to make the integration as the bottleneck. So we want to make sure that it just opens up for any type of requirement in the future. So that's the next part. So. Any more questions? Yeah, sure.
So the correlation process of the call itself takes good amount of time. Let's say, so you receive a CDR, right? So by the time you receive a CDR, the correlation is done by, I believe, sprint side to generate the CDR. So how much is the lag in between you receiving a CDR, they correlating the data, and fraud call is in progress, which is, how much time you save basically?
Yeah. So. So very good question. So in our case, what they are doing in this particular business case, they are doing reactive analysis. So they are not really checking the real-time fraud. That is a separate initiative altogether, where they are actually using the oral characteristic of the caller, and they are actually implementing that right now. So if you're calling, and then they would hear the frequency, the voice of the caller, and then they use with existing characteristics of the caller to determine whether the call real time is fraud call or not. So it will go route to different agent who is experienced in dealing that type of call. In this case, they are doing reactive. So they have call has already been made, right? The CDR, when you have the CDR, that means call is already done. They are finding out if it was a fraudulent call. So the window of opportunity is like very small, because if they know that fraud has happened, they want to stop that immediately. So, all right. Any more questions? So,
Is it a long time?
it's like 5 minutes. Within 5 minutes, they have to like call happened. CDR record came in. Within 5 minutes, they have to get the data all the way to their rules engine. So it's like a very small opportunity. Exactly, reactive. So they block the accounts. They create tickets for the accounts team to like do the preventive measures. So
once it goes to high, then it becomes Hadoop, it becomes IPA. So your value add is.
yeah. So all these orange components, right? What you see here. So this is our value add. This is our value add. The work management within the ingestion high speed is our value add. This transformation through any of the engines which you have is our value add. So it's all happening through the Deoda server. So, yes, please.
So how is your injection different from like a flow injection? Assuming Apache flow?
So our ingestion is we started in terms of optimizing the ingestion. So if you are loading data from The standard source systems like Oracle, we use native connectors. So to optimize the ingestion, if you are loading data from files, you can run in parallel threads. So we have optimized it in such a way that your data ingestion should become fast enough, not just by a single file by file type of ingestion. So we have done that optimization, and would love to discuss that in more detail after the session if you would like to understand more. So that's a very good question, actually. It depends on how your configuration is. So if you have agents sitting in the cluster, then the data directly goes from that source agent to the target agent. So that data doesn't have an extra hop as you would have like in some other architectures which are out there in the market. So.
But you're feeding the data to that box in the center, which would be Hive or everything else for the processing.
Oh, here.
Yeah, over here, that whole green box.
Yes.
Actually, the ingestion is feeding that green box.
Correct.
So my question is, where is the ingestion putting the data so that the green box can pick it up?
So it is actually pushing it all the way into the, like let's say you have used Hive as the sink, right? So you're loading data into Hive, using Hive as a meta store. So it'll actually go use the Hive interface and then start loading the data directly into Hive. So you'll have it in managed tables.
Is that Hive streaming or?
Hive?
Is that Hive streaming?
No, I have not heard of that.
The landing zone 1 to green box, what is the mechanism to move the data?
Yeah, so it's like, it's a custom component which basically is generated at the runtime. So if you are loading data from file into Hive, right, so it'll actually run that code, ingestion code on the edge node so that it can run and ingest the data. Why don't we take that offline and then discuss it after the session? We are right at 3 minutes, so I can take one last question if anyone has. If not, thank you so much for coming down. Really appreciated you all coming. Thank you.